Profitable dairy beef production comes from finding the right balance between production costs and cattle performance. A low-cost production system for dairy-bred calves, which relies predominantly on homegrown forage, was trialled between 2017 and 2018. The study involved 70 steer calves. Half were Hereford Cross Holstein Friesian, and the other half were pure Holstein Friesians. This system aimed to maximise output from grazed grass, reduce production costs by winter grazing fodder beet, and aimed to avoid any housing period. Target growth rates during the first grazing season were 1 kilo a day. Over the winter on fodder beet it was 0.7 and then 1.3 for the second season at grass. Performance during the rearing phase was similar between the two breeds, with both averaging around 150 kilograms. The calves were introduced to baled silage and compound feed to aid transition to a fully grazed diet. They then grazed for a month whilst also having access to shelter and feed. In April, cattle began rotational grazing on the grazing platform. The study used a 12-hectare field split into 10 paddocks. A mobile water pipe was laid out to enable easy movement of water for the cattle. Managing grazing efficiently is fundamental to the success of this system. This enables optimal performance of grass with high levels of utilisation. A rising plate meter was used to take measurements every 7 to 10 days during the grazing season. Cattle entered paddocks at 2,500 kilos of dry matter per hectare and left at 1,500. On average, the cattle spent 1 to 3 days in a paddock dependent on grass growth. All grass growth data helped the stockman plan the rotation. The green columns in the graph showed the grass availability. The blue line showed the predicted grass demand from the growing cattle. In this example, supply is good and there is currently no deficit, which would be evident as the blue line being above the green columns. Grass quality was good, with energy levels at 13 ME and crude protein levels at around 18.5%. The summer of 2017 was notable for its low rainfall. The drought had a major effect on grass growth in July, which affected the overall growth rates of the cattle. Both groups of calves grew more slowly. Hereford crosses were on average 17 kilos heavier than the Holstein Friesians. The cattle were outwintered on fodder beet. A field used for grazing fodder beet should be free draining with a gentle gradient. It is important to minimise the risk of runoff with the use of buffer strips. Silage bales were placed in the field in June, thereby avoiding soil damage by machinery. A grass runback was left in the field to help the cattle transition to the fodder beet. The diagram shows a plan of the fodder beet field during the winter. In preparation for grazing the fodder beet, the calves were given a clostridial vaccine and a high mineral bolus. The calves were transitioned gradually onto the beet to avoid acidosis. Initially, some beet was lifted and fed to cattle while still on grass to start the transition. When the cattle moved to the fodder beet, they had access to an area of grass runback, whilst the amount of fodder beet offered each day was gradually increased and the amount of silage reduced over a 3-week period. The cattle were strip grazed from late October to early April, and the electric fence was moved daily to provide sufficient intake for the cattle based on a predicted dry matter intake of 2.5% of body weight. The fodder beet was nutritionally analysed. It is interesting to note the difference between the root and the leaves. The root was higher in dry matter, sugar and energy, while the leaves were higher in protein. The average daily live weight gain whilst on the fodder beet was 0.45 for the Hereford crosses and was lower at 0.34 kilos a day for the Holstein Friesians. These growth rates were below target, probably due to the combination of high rainfall and below average temperatures for that winter. The poor weather conditions in early spring 2018 meant that grass growth on the grazing platform was estimated to be 3 to 4 weeks behind the previous year. Cattle were eventually turned out in mid-April. The 2018 grazing season was difficult due to the drought. Consequently, cattle were supplemented daily with 5 kilograms a head of compound feed to maintain growth rates from mid-August. The cattle were sent for slaughter in 6 batches between July and January. The mean sale date of the Hereford cross was 6 weeks earlier than the Holstein Friesian. All Hereford cattle were sent for slaughter directly from grass. 15% of the Holstein Friesians failed to finish off grass and were housed at the end of November and fed a total mixed ration before going to slaughter in January. Carcasses from the Hereford Cross cattle classified at an average conformation of O+ and a fat class of 3/4L, compared with the Holstein Friesians, which had a conformation of P+/O- and a fat class of 2/3. Carcass weights for both breed types were similar at 320 kilograms. However, the Hereford Crosses killed out on average 1.4% higher. When we review the whole system, the Hereford Cross cattle grew faster than the Holstein Friesian steers during their first grazing season and also on the fodder beet, resulting in them being ready for slaughter earlier. The Hereford Crosses also produced carcasses of better conformation and fat class. The pure dairy bred steers struggled to finish off grass and achieve the required carcass fat class and also had a poorer killing out percentage. The need to house a proportion of the dairy steers incurred additional costs. Both breeds had a positive net margin. The difficult winter conditions and then the drought during the following summer hampered cattle growth rates, but was a good test for such a system which needs to be able to withstand extreme weather conditions. The key success factors in this type of system are excellent grassland management that is able to respond to the different growing conditions whilst maintaining cattle performance and output per hectare, transitioning the cattle to maximise fodder beet intakes and potential cattle growth rates, the ability to graze fodder beet to prevent long-term soil damage or loss.